So let's have a look at some of the examples with these surds. If I said to you 8a take away 3a, I would get 5a's. So if I had 8 tens minus 3 tens, I'd end up with 5 tens. If I had 8 hundreds minus 3 hundreds, I'd have 5 hundreds. Same goes for surds. If I've got 8 lots of root 6 minus 3 lots of root 6, I get 5 lots of root 6, because 8 take away 3 is 5. If I'm going to add them, so if I've got 5 root 2 plus 2 root 2, well, I've got 5 and 2 is 7 lots of root 2. That's the same as saying 5a plus 2a equals 7a. Yeah, so 5 thousandths plus 2 thousandths equals 7 thousandths. 5 halves plus 2 halves equals 7 halves. That sort of thing. Okay, let's have a look when it gets a little bit more tricky. Not too tricky, but a little bit. If we've got multiple different terms, I'll just get a colour. So say I've got 4 root 7 plus 2 root 5 minus 3 root 7 plus 8 root 5. I have to start looking, just like with algebra, for like terms. This one has got a root 7 in it, and so does this one. So those two are like terms. Oops-a-daisy, sorry. If I've got the other two, can you see that? Those two are also like terms. So if I was to add the purple ones together, 2 root 5 plus 8 root 5, I would get 10 root 5. Alright, I've got 10 lots of root 5, 2 plus 8. If I look at the red ones, I've got 4 minus 3, so I've only got one lot of, plus one lot of, root 7 left over. And I could have written it the other way. I could have written root 7 plus 10 root 5 makes not one iota of difference. Usually we like to keep the first term if it's a positive we can, but that's how you do it. So look for like terms. This is like 4a minus 3a is 1a, and 2b plus 8b is 10b. Let's have a look at another example. This one's a little bit more complicated. So 4 root 2 I can't simplify, but can you see, thinking back to our perfect squares, that 50 is actually 25 times 2. So now I've got 4 root 2 plus, what is the square root of 25? Well, if I had a square at an area of 25, the square root of that would tell me the side length of that square, and that would be 5. So this is actually 5 root 2 minus root 2. It's still the same. So I've got 4 lots of root 2 plus 5 lots of root 2, that's 9 root 2. Take away 1 lot of root 2 is 8 square root 2. Last one, square root of 45 plus 2 root 5 plus 7 root 5. So again, you're still having to look for perfect squares, because that's what these square roots help us find, because square root of a number I can actually do. So if I thought of 45 as 9 times 5, 9 fives are 45, plus 2 root 5 plus 7 root 5. Now I can say, okay, what is the square root of 9? Well, the square root of 9, if I had an area of 9, the side length would be 3. So this is actually 3 root 5 plus 2 root 5 plus 7 root 5. 3 and 2 is 5, plus 7 is 12, so that actually equals 12 root 5. Any of these you can check on your calculator, so feel free.